Good morning, students, once again. So here we are with the next lecture on light. If you remember, we were discussing in the previous lecture we were discussing some of the practical consequences of refraction in real life that we see. Okay, and we had also discussed this particular case. As you can see, the diagram once again I have drawn. You can treat this to be a piece of coin or whatever, any small object kept below water. Okay, so you can treat this particular medium to be all water, or it can be glass also. Okay, so it is kept right below the glass, or it is kept inside the water at the very depth, at the very bottom. Okay, now this is air medium, as you can see. So this becomes the denser medium, this becomes the rarer medium, and the rays of light are going to start from the denser medium and they are going to travel into the rarer medium. So they obviously are going to bend away from the normal. As you have seen, for image formation we will always draw minimum two rays. So these are the two rays that are coming out and they are diverging away from the normal. Okay, so we will produce them backwards with a dotted line, because this image that will be formed, this will be the virtual image that will be formed. Okay, so this object we will call the real object, because that's where the actual object is. Whereas to the eyes of a person who is seeing, who is watching from the air, if you observe the person standing over here, if he observes the coin, he will feel, it will appear to him that this coin, which is actually kept here, is not kept here, but it is kept here. Okay, so that is the reason why we are calling this coin or this image to be the apparent image, because this is not the reality, this is what is appearing to his eyes. Okay, why is it appearing so to his eyes? Because of the bending of the light that has taken place at this surface of separation. Okay, so that bending has been according to the rule, denser to rarer, it bends away from the normal. So once you draw these two rays, you produce them backwards, they appear to meet at this particular point. So this particular point will be known as the apparent image, whereas this is the real object. Okay, so you can say that this is the apparent object and this is the real object, and in other words you can say that this is the object and this is the image. Okay, so obviously it is very obvious to our eyes that this image that is getting formed, it is slightly raised from the actual position of the object. Okay, so there are some terms that we had discussed. This will become the real depth, because this is where the real object is, and this will become the apparent depth, AD, capital A, small capital D. This is known as the apparent depth, because this is where the image has been formed, or this is where the apparent object is. Okay, so obviously then how much will this portion be from here to here? We can call this as the shift, because the real object is kept here and it is appearing to be shifted upwards by this amount. Okay, so that is why this amount has been known as has been called as the shift. Okay, so today's lecture will basically establish a relationship between real depth, apparent depth, and the mu, which is the refractive index of the denser medium with respect to the air. Okay, so we will directly go to the formula and we will solve a few questions. We have refractive index of the denser medium with respect to air. I hope you remember how to read this. This is refractive index of the medium with respect to air. Now obviously if we are taking one medium to be air, the other medium will be the denser medium. Okay, so this will be equal to the real depth, which I have called RD in the diagram, okay, upon the apparent depth, okay, which I have called AD in the diagram. Okay, so if this is the formula, then what will be the shift according to the diagram that I have drawn? Can you tell me how much shift will be geometrically by looking at the diagram? Yes, we can see obviously that it is this shift which is going to be added to the apparent depth to get the real depth. Or in other words, you can say that the shift can be written as the real depth minus the apparent depth. okay, because this full thing is the real depth. If you subtract the apparent depth portion, you will get the leftover portion, which is known as the shift. Okay, so these are the two things that we have to continuously keep operating on, because these will be the two things required for the solution of our numericals. Okay, now, so if you see, if we want to bring in the second equation, now if I call this to be equation number 1 and this to be equation number 2, you can see that there is no refractive index appearing in the shift. So if you get a question in which they give you the refractive index of the medium, they give you real depth, and they ask you for the shift, so in that case we need to have a formula of shift which has refractive index also in it. So it is very simple, you can just proceed from here. You have shift formula is equal to RD, which is obviously the real depth, minus, now you see in place of this apparent depth, which is this in the first formula, if you see, apparent depth can be taken this side and refractive index can come this side simply by taking apparent depth to the left hand side. This is dividing over here. When it goes to the left hand side, it will multiply. Mu is in the numerator over here. When it goes to the other side, it becomes denominator. Okay, so very easily from the first equation I can write AD is equal to RD upon mu. Okay. Okay, so I have taken this here, I have taken this here, so this is what I get. Okay, so this apparent depth now I can replace over here, so this is going to become RD upon refractive index of the medium with respect to air. Okay, so now finally you get shift is equal to, now you see RD and RD, which is the real depth, it can be taken common, so this will become 1 minus, now obviously RD has been taken common, so you will have 1 left here, minus, now this will become 1 upon refractive index of medium with respect to air. Okay, so this is the formula that you have to remember with regards to the shift, and this is the other formula that you have to remember. Okay, so these two formula will help you in calculating either the real depth, apparent depth, refractive index, or the shift. Please remember that you will always be given two things and asked the third thing. Okay, so we will quickly take up one numerical, but before taking up that numerical, let us discuss the factors that will affect this particular shift, because again it is common knowledge or common experience from what we have studied till now, that this value of shift actually cannot remain constant for all different mediums, for all different atmospheres. Okay, so we need to establish some variables or some quantities on which this shift will depend. Okay. Okay, so here are the factors that I have listed. As you can see, shift depends upon, so by how much is the coin going to be appeared raised is going to depend upon these three factors primarily. So what are they? Obviously the first one is refractive index, which is what we had called mu of the medium. So denser the medium, more optically dense is the medium, more will be the shift. If you replace this particular dense medium with another medium which is even more dense, optically more dense, so by saying that a medium has optically more density, what we mean is an even greater value of mu. Okay, so what we can simply say here is, as long as your mu value keeps on increasing, your shift will also keep on increasing. Okay, because obviously since mu is going to be much more, therefore the refraction is going to be much more, and therefore it will appear even more raised up. Okay, so there is a direct relationship between the refractive index of the denser medium that we are taking and the shift. Then the next that comes is the thickness of the medium. So more thick is the medium, more light, more will be the distance traveled by the light, so more will be the refraction. So because of that, there will be more shift. So these two factors, as we understand, the refractive index of the medium and the thickness of the medium, they are directly going to affect the value of the shift. more the value of refractive index, more the value of thickness, more will be the shift. Now coming to the last part, or the color aspect, which we obviously know, we can relate color to the wavelength of the light. So this particular light that we are seeing, that is traveling, if we are taking it to be of different colors or of different wavelengths, then obviously the value of the shift will change. But this time the value of the shift will be inversely related to the wavelength or the color of the light. So we can say that as and when the lambda drops, okay, as and when the wavelength drops, you will have an increase in the shift. You will have an increase in the shift. So this is basically, this relationship is inverse. Why? If you recall, the wavelength of the violet light is the lowest, okay. So if you remember, we had discussed lambda, the value of the wavelength. If we start from the violet, VIBGYOR, this was the band of the 7 colors that we spoke about, and lambda value actually increased in this particular fashion. And to give you the exact value once again, it was around 4000 angstrom, okay, for violet color, and for red color it was somewhere around 8000 angstrom. So as you can see, the lambda value for the violet color was the lowest, but remember, violet color was the one that was bending the most, okay, because as long as the particular color has a very low wavelength, it will correspondingly have a high refractive index, okay. So what you can remember, for ease of remembrance, what you can remember in your minds is, lower the value of wavelength, more is the refractive index, okay. So lower the value of wavelength, you can see lambda is the symbol for wavelength, so lower is the value of wavelength, more will be the refractive index, and we have seen that more the refractive index means more the shift, okay. So this lambda, or the color of the light or the wavelength of the light, is inversely related to the shift. Lesser the wavelength, more the shift. More the wavelength, less the shift, okay. So although the first two factors are directly related, so you can write here also, if the thickness increases, you will have shift value also increasing, okay. So these two are directly related. You can see this one and this one, they have direct relationship, whereas this one has an indirect or inverse relationship, okay. And mind you, this formula that we discussed, formula about the real depth, apparent depth, shift and refractive index, that has a very important assumption kept in mind, that the person is more or less watching from vertically above the coin, okay. So that point we'll have to remember. Now we'll quickly go on to solve one question, so that you are able to solve some questions on your own also. These questions are quite simple, simply based on the two formulae that we have studied. Okay, so here is a formula based on that same concept, and please remember, this is a practical case scenario, or the practical consequence of refraction of light through plane surfaces or at plane surfaces, okay. So let us read the question first. A coin is placed at the bottom of a beaker, okay. So there is a beaker. You can always draw a very a rough sort of a diagram, although I don't think you will require the diagram over here. So this is kind of a beaker that is there. It is filled with what? Containing water, okay. So it has water inside it to a depth of 12 centimeter, okay. So this entire depth that you have is 12 centimeters. So obviously the coin is kept somewhere here, okay. So what is this 12 centimeter? Immediately you will recognize that this is nothing but the real depth, okay. So the first piece of information that we have is RD is equal to 12 centimeters. So we have started with our solution, okay. By what height does the coin appear to be raised, okay. So obviously after successive after refraction through this particular surface, as you can see, I'll not draw the diagram using the scale this time, so you can easily draw a diagram something like this. So you have, okay, so suppose that the eye, this eye sees that the coin is over here. Okay, so what is this second line stating? You see, by what height does the coin appear to be raised? So by what height the coin appears to be raised? They are actually talking about this height, and we have just discussed, we have just studied a few minutes back that this particular portion is known as the shift. Okay, this particular portion is known as the shift. So what they are asking is the shift. Okay, and obviously what is this portion? This is your apparent depth. Okay, so this portion you will. So although this diagram was not really required because we have this diagram in our mind, but still it is always going to be easier for you to solve if you can analyze the diagram or draw a rough diagram. Okay, so what are they asking? They are asking you shift. So we will keep shift unknown for the time being when seen from vertically above. Okay, and they have given the value of refractive index of water with respect to air, that is 4/3. Okay, so as you can see here, they have not really given you the apparent depth. They have given you two things, real depth and the refractive index, and they are asking you for the shift. So if you remember that second formula that we have studied, shift is equal to real depth multiplied by 1 minus 1 upon refractive index of medium with respect to air. So here obviously the medium is water, so I am going to write it like this. Now shift value has to be calculated. RD value I will keep as 12, and in brackets 1 minus 1 upon, so this value is 4/3, so 4 will come here, and by 3, so 3 comes at the top. So instead of writing it like this, I can simply write this. Okay, so that is what is there, equal to, now the remaining part is only simple calculation, so you can 1 minus 3/4 is 1/4. Okay, so if you're not directly comfortable doing it, take the LCM and you can do that. So 4 3s are 12. So this comes out to be 3 centimeters. So what is this value, 3 centimeter that has come out? That is the shift value that has come out, and shift is nothing but the height by which the coin appears to be raised. So it is this, which is 3 centimeters. So obviously now if the second part of this question had been to find out the apparent depth, you would have easily calculated the apparent depth by subtracting 12 minus the shift, which is 3, so that will come out to be 9 centimeters. But they have not asked this in this question, so we will let it be. So this is what is there as far as the practical consequence of refraction is concerned. Now in the next topic we will discuss a very important concept, which is the concept of total internal reflection and critical angle. Okay, so that lecture is going to be a very important, although a very interesting one also. Okay, but it is going to be very important. So please, before we go ahead and go into that lecture, I would urge you to revise whatever we have done till now, because very soon now we are going to enter into the more complex details of light. Okay, so for the time being, goodbye.